Corinna, Italo just started the live streaming, so we are ready to go anytime Nadia joins.
Okay, I would not start it yet, I guess, until she comes. Sorry, because yeah, we should perhaps.
How many time it will take to start the meeting? Actually, it hasn't started.
Sorry.
Okay, the meeting hasn't started, or it will start some.
It is supposed the lecture is supposed to start at 7:40, but we are still waiting for Nadia, so I would stop the live streaming or yeah, I don't know if you want to.
Okay, no problem. Okay, no problem.
But we can wait for her. I hope she understood the right time. She's in London, so I don't know if there is a misunderstanding with the time.
Okay, fine. No problem.
Thank you. Otherwise, I'll try to give a lecture. No, I'm joking.
Okay, no problem.
Or you guys should tell us about. Okay. I think Nadia answered. So let me see. Okay. She said her understanding was that we are starting in an hour. So yeah, there was a slight misunderstanding. Okay, so she will join and then Mattia will say a few words about the protocol and then I'll introduce her. Is that okay? Okay.
Yeah, that works with me.
Hi.
Hi, Nadia. How are you?
Hi. I'm so sorry. I completely thought it was 5 to 6 my time. I thought that was the time I chose. So I was lucky I had the laptop open. Otherwise, I wouldn't have seen your messages.
So I will just make a brief announcement to explain the procedure. Corinna will introduce yourself and then we'll start. So
okay.
welcome everyone to the first session of ISSTA this summer school. Thank you very much for joining. So the way in which this session will work is that we are gonna mute everyone except Nadia that will give the talk. And then if you want to ask questions, there is a channel on Slack. So for the summer school, please post questions there. And Corinna will read all the questions at the end of the talk. Now I let Corinna introduce Nadia.
Thank you, Mattia, and hello, everybody. It is my pleasure to introduce Nadia Alshahwan, who will give the first lecture in the summer school for ISSTA 2020, the first virtual ISSTA ever. And Nadia is a software engineer in testing and verification at Facebook. She is part of the Sapiens automated testing team. She received a PhD from UCL in web application testing, and she was supervised by Professor Mark Harman. She also worked as a researcher in security and model-based testing. And prior to joining Facebook, she was an information architect at JP Morgan. And today she will tell us about testing at Facebook with Sapiens. Please, Nadia, start.
Hi, thank you very much, Corinna, for the introduction. I'm sorry for being a little bit late. Okay, so I'm going to start sharing my slides. Okay. Okay, so I'm a software engineer at Facebook, and I've been with Facebook for about 2 years. But throughout my career, I did both research. So I did my PhD, and I also worked as a researcher for a few years. And I also worked in other companies. So I kind of have both industry and academic background. So today I want to talk to you about Sapiens, which is a testing tool that we are using at Facebook, and it's I'm part of the team that works on this tool. So I'll begin by just giving a little bit of a history of Sapiens. So Sapiens was a research project at UCL, the people who are working on the project, which are these people, Mark, Yue, and Kerr, they founded a startup based on this tool that they created to test apps. And then they got the chance to do a demo for some engineers at Facebook. And Facebook really liked the tool, so they acquired it. But they also hired the founders as engineers at Facebook to work on the tool. So what they did was they spent the first year doing a proof of concept of kind of adapting this research tool to the Facebook environment. This was very successful. And it was, so the tool was finding crashes and was kind of integrated within a year, integrated within the Facebook continuous integration system. So from there, the team was expanded to productionize the tool, and then a lot of other people joined with different backgrounds. So some people who only have industry background, and some people who have similar backgrounds, who came from research, PhD graduates and researchers and so on. So the tool has evolved a lot since it started. So it started by being a search-based testing tool. So it was using search-based software engineering, but now it uses a completely different algorithm. And today I'll talk about how the tool is today and how we're using it. So we all had this experience where we use an app, and then you're doing something, you're in the middle of something, and suddenly the app crashes. And it's a very unpleasant experience, and something that us as anyone who's released an app wants to avoid, because it could put people off and make them use the app less. And it's also not nice to kind of be in the middle of something. For example, imagine writing a message and like writing a comment, and you just wrote like 3 or 4 lines, and then the app crashes and you lost everything you wrote. So we definitely want to avoid these situations. And what people do is they, traditionally, they have someone like an engineer sitting down and manually writing end-to-end tests to make sure that the flow is working, and like a lot of other tests, integration, unit tests, whatever. So what we want to do is to, but the problem with that is it's a manual and tedious process. So it takes a lot of time, and then the tests need to be maintained every time the screen changes a little bit, and it's very time consuming. So what we want is something, what we're hoping for is like automated tests that have high coverage. So when we say coverage, we don't just mean code coverage, but we also mean device coverage, like different types of devices, because some issues could only happen on specific devices. You want to have different user profiles, different type of users, because maybe, again, some issues only happen with specific types of users. So coverage is not just the code coverage of the app, but it can cover a lot of other types of coverage. And you also want these tests to be high quality. So we talked a lot about flakiness and tests that are hard to maintain, because every small change could break the whole thing. So we want something that is that doesn't have flakiness or has very low flakiness, and also it doesn't need any maintenance, and that's why automated tests are attractive. And then we also want to not just test. So when developers write tests, they write the flows they expect the user to use. So what we want is something that can do the unexpected, because from experience, we see that most issues that happen are that users use the app in a way that we didn't expect them to use it. And that's why, for example, the app crashes. So what we want is something that would explore behavior that is unexpected as well, from the point of view of the developer. So that's why that's why we think the solution is something like Sapiens. So Sapiens would generate the tests and hopefully have all these characteristics. So what Sapiens does, it opens the app and then it just kind of scrolls over it, simulating a human. It will use the app just like a human would do. And when I say simulate, I mean it will scroll and click, and I don't mean that it necessarily will behave exactly like a real user. So that's something that would be good to have, but I'm not claiming it exists right now, that it simulates user behavior. So then when the app crashes, then Sapiens can report that. So when we look at this graph, if you look at the way, the point of time when you find an issue, it's much, it requires a lot less resources and time and effort to fix an issue if you find it early in the development life cycle. So for example, if we look here at the line, if you find an issue while you're writing the code, that's the best time, because you know exactly what you're changing. You can quickly discover that, oh, it's because of this thing I changed, and it's the least cost or resource use associated with fixing the issue. And then as you go through the development life cycle, it becomes harder and harder. So for example, if it's at code review, it's not too bad, because you can, maybe it's only been a day or a few hours, you still remember what you did. But once it gets into the like alpha or beta or release, then it becomes more difficult, because first of all, the developer is removed from the time they did the change, so they might not remember what they did or why they did it. But also a lot of other changes have landed, and then you start getting into the situation where you don't know which change is your change or the other person's change that caused the issue, or the combination. So then it becomes difficult it takes more time to debug, it takes more time to get back into the context and remember what was changed and why. So that's why we want to find things as early as possible. So let's say at code review time. Of course, we would want to find it earlier, but let's say this is a point that is good to test that. So the way Sapiens is integrated at Facebook is that, so this is like the normal process in most companies. Engineer writes code, and then when they finish writing, they submit their change. And then all the other engineers can review the change and accept it or reject it, right? And in Facebook, we use a tool called Fabricator, which is like the place you submit the change to, and then other people can see your change exactly and comment on it. And then every new change would trigger the continuous integration process. So in the case of apps, it will trigger building a new app. So then at this point, what we will do is Sapiens will pick up this new build and run on it, right? So it's kind of integrated into the continuous integrations process. So it's not triggered manually by anyone. As soon as you submit a change and the system, just as it is before even Sapiens existed, builds the app with this change, then we would pick up the new build and test it. And then if we find any crashes, we would go back and comment on the diff itself. So we will try to triage the crash that happened to a line of code that you changed, and then we will go and comment on that line and say, we think that a crash was thrown from this line, please have a look, because you also never know if this was caused by the change or it's pre-existing and it's just by chance that they touched the same line. So then in this case, we found that the engineers it's a very high chance that they would fix it, even if they didn't cause it, just because they're so close to the change, they can easily kind of debug and change. So I think it was the fix rate was something in the 90s, like 95% or something. I don't remember the exact number. And one thing I just want to highlight is that when Sapiens runs, so it has these three components. So it's get runtime, which basically means that you get what's on the screen, so you know what's on the screen, and then it would decide what to do. So that's sending the gesture, and then it will inspect the state again to see what's the effect of the action that was executed. But all the dealing with the emulators and all the backend is kind of like the emulator we're running on, or the simulator in case of iOS, and the handling of that. There's another team that is working on that. So this is good because you only focus on the things where it's your strength. So our strength is, like, I hope, is this kind of looking at this algorithm, developing this algorithm, and we don't need to worry about emulators and scalability. And another team is specialized in that, and we just use their service. So that's basically the way it runs. So then what we do is we run in parallel many of these of this algorithm, and it's running all over. I think I have it in the next slide. So Sapiens started by deploying on the Facebook app for Android, and then it was expanded to cover Messenger, Instagram, Workplace, I think WhatsApp now even, and yeah, a few like Ads Manager, a few other apps that are part of the Facebook set of apps. And we also expanded to iOS, and we recently started also kind of testing www, but very early days. Sorry, like the web interface, I mean. Okay, so let's go into the details of how the algorithm works in the Sapiens, this new algorithm works. So the first thing is we will, so it's an algorithm we call view ranking, and so we'll just go through like what are the steps. So first step, it will open the app in the emulator and it will log in. So the login, we just like hard code it, like whoever wants to onboard an app will just say, oh, you go to the first box, you type this and then this, and then from there, we would wait for the app to respond. So basically for it to load the app, and then we look at the screen. And then we will detect all the UI actions on the screen. So for example, all the clicks, all the long clicks, all the swipes, all the text boxes, everything. And then we will start to build a graph of those actions and how they relate to each other. So, so for example, on the screen, you have this action 1, 2, and 3, let's say, for example, which is like the little profile circle. There's like, let's say, a button there, and then there's this image you can click. So we would go and start a graph with these 3 elements. This is the beginning of our graph. So we'll store these actions, and then we will, the next step is we will rank those actions. And for the ranking, we use, it's a pluggable algorithm, so you can rank using any algorithm you want. But we use something that is based on 2 things. First, did we click this thing or not? So so for example, if something has been clicked before, then it will have less, a lower ranking. And if it's new, then it will be high on the ranking. But then if everything, and I'll go into this more. So if everything is equal, then we will click the buttons that from our previous clicks, we saw that behind them, there's a lot of new things that we didn't click. So I'll kind of show the example here. So what we will do is we look at the screen, extract all the actions, and then we will rank them, and then we will execute the highest ranked action. After that, we will wait for the app to respond again, and then we will again look at the screen, see what the actions are. So for example, here, when we clicked on action 1, we saw this 4 and 5. So we add them to our graph, and then we will then rank again. So again, here it's both unknowns. So we would, like, we've never clicked either of those. So we just click one randomly. So let's say we clicked 4. And then that led us back somehow to the first screen. So now again, we have 1, 2, and 3. Okay, so now in this case, so again, we will look at the screen, what are all the actions, and rank them. But now the ranking will be different because we've clicked it, action number 1, we clicked that before, so we wouldn't, so that would have a lower score. So we would do 2 or 3. And then we will continue until, like, you have this big graph that is all built up of all the actions and how they relate to each other. And if you get to the point where you're again at the first, and then, so I'm stopping a little bit because at the side are covering my graph, so I can't tell you I can't see what, I'm just trying to get rid of it. Okay, anyway, it doesn't matter. You can see it, so I guess that's enough. So now if I get again to the screen and all 3 actions have been clicked before, then I would click the one that leads to something that is unclicked, and I will use the one that has the shortest distance to the unclicked. So for example, all these 3 might lead to the unclicked action, but I'll choose the one that gets me the fastest, right? And that's how it works. So what we do is, it's not like one emulator, like we don't test the app with one emulator at a time. We test it with 20 or 40 or whatever we need, like it's a configurable. So you choose how many you want to run. And then they learn from each other. So you have a shared state, and all the different runs add to the graph. So then the other runs can take a different path, basically. So we have a few challenges that developing this that we found, and these are like basically kind of a summary of the top 3. So what, not the top 3, but basically what we want to do is we want to start from scratch every time, and this is to have reproducibility, so that if we find the crash, we can rerun the whole sequence. So if we are starting from let's say if we reuse the users several times, so their state is changed, or then you would have, then reproducibility would be lower. So for example, let's say the first time you logged in, and then you added a post, and then let's say, so we start with a state where you maybe have some messages in your inbox or something, just to make it a bit richer. So let's say you started and you went and deleted one of the messages. So then if I use the same user again to run the same sequence of events, then the message is already deleted. So then that would make it not reproducible. So that sort of thing. So that's why we always want to start from scratch, so that we know that we can reproduce. And we want to finish quickly because, I mean, it depends on where you are, but for example, for Facebook, there's like a lot of new changes every few minutes, so you can't take too long testing the app. And you want to have high coverage. So all of this kind of in combination makes it a bit challenging. So one of the challenges we have, and this is something that I think is a problem that exists for a lot of things. It's kind of, how do you identify something uniquely, right? So it's a generic problem. For example, let's say you had, so just in general, let's say you had crashes. How do you know that this crash is new, or all is the same or different, right? So and same with anything that has like some text and you want to compare. It's a generic problem, but it applies here as well. So we are building this whole algorithm on identifying actions and then trying to score these actions based on what they lead to, or what parts of the app they lead to. And if you don't identify those actions correctly, then your whole algorithm is not reliable, right? So for example, if let's say if you have a button and you say, oh, if I click this button, it takes me to this big part of the app I've never seen before, and you rank this high, but then next time you come, the button, let's say you swiped a little bit up and the button went up a bit. Now the position changed, so now to you it appears as a new. Let's say you used to identify, to use the position and the name and the class name and everything. So if the position changes, you think it's a new action and it isn't. And then you go and waste time clicking it again while you already clicked it, let's say. So identifying things uniquely is very important when you're ranking things. So it's actually very important in any UI testing algorithm that is not random, that is based on like learning something. So for example, what we started with is we have these, okay, we take the properties, so this is for Android, we take the properties of the view. So the class name, the resource ID, the screen position, the size, the text, and then we say, okay, we hash those and that's our identifier for the action. But then what we found is this is a fun example. This was a text box, and we just type this word randomly. Every time you type the word, the size of the box changes, because that's how text boxes sometimes work. It's like if you type, the text box becomes bigger. So because it's becoming bigger, and we prioritize text usually in our algorithm, it just becomes an infinite loop where we're just inserting text to this because we keep ranking it the highest. So what we did for that is like, okay, let's remove the screen position for text boxes, right? But this led to another problem. For example, here, all these 4 boxes have the same class, they don't have resource ID because it's not everyone uses resource ID, and they have the same size, and they are of type text. But because we removed the position, now we think all of these are the same. So we would just go and put something in one of them and ignore the rest. So then that's something we don't want to happen. This is another example is if you take class name, resource ID, screen position, size, and text, for example, these emojis, they have different positions, right? Each one of them has a different position. But do we want to click on all of them? There's about 250. Do we want to spend all our time just clicking on every single emoji? So that's why you want to think about these problems and try to come up with the solutions. For example, for this, we kind of try to recognize lists or things that are in the same list, and then as soon as we click one of them, we deprioritize the rest, just so that, because you can have the same with, let's say you're choosing a time zone or something, so you have like, I don't know, a lot of choices, but they all kind of give the same effect. So maybe you don't want to prioritize them. Otherwise, you always get stuck in this kind of change the color, choose the emoji or something like that. Yeah, I guess, thank you. So that's kind of all what I wanted to cover. But I would like to say that if you, so Facebook offers a lot of internships, and for both PhD students and for masters and undergrad. So if anyone's interested, and you can work on things like this, so there's a lot of other kind of researchy type teams, like for example Infer, that do static analysis. So if you're interested, please just email me, and I can refer you for an internship or something.
Okay, thank you very much for the presentation, and sorry again for the misunderstanding with the starting time. So I understand that we have time for a few questions, and I will start by reading a few questions from Slack. Can you hear me? Hello?
Yes, are you talking to me?
Yes.
Yes, I can hear you.
Ah, okay, great. So the first question from Milos Gligoric. So he's asking, how much time do reviewers spend on reading code changes? And is there any max size of changes that one can submit? This is related to the slides at the beginning that you presented.
Yes, so there's no limit on the size of changes, but the recommendation is usually to split your changes to single pieces, like single concepts, just to make it easier to review. So they're not too, they're only big if someone is doing like refactoring, like I'm just going to move this because it doesn't make sense to be in this folder. So in that case, the lines become big, but the change itself is easy to review because it's just moved from one place to another. And the time, it can be from a few minutes to a couple of days, right? It depends on the team and how, like, the priority of the change, and so it could go from very quick. So that's why sometimes like testing automatically would miss that. So you would comment on the diff after it landed, for example. So, but we found that people even then kind of sometimes go and change it or fix the issue. And sometimes it could be days, depending on also how many changes are requested and like back and forth on them.
Okay, great, thank you. And we have another question from Milos again. So how do the results compare if you do the ranking versus if you do no ranking? And this is related to the view ranking that you presented. Hello?
Okay.
Did you hear my question?
No, I'm sorry, I didn't hear it.
Okay. There was another question from Slack, again from Milos, and he was asking, how do the results compare if you do the ranking versus no ranking?
So if you don't do the ranking, so you're just kind of picking randomly something and executing, then the coverage is in general lower. But just like anything that is random, you have like a box plot that is wider, right? So it could be very low, it just keeps picking the same thing, or it could be very very high just by chance once in a while. But like the median is always kind of like much higher on the non-random approach, the ranking approach.
Okay, I see. I see that Milos is nodding, so I guess he agrees. While waiting for more, okay, there is another question from Mattia Fazzini. So can you tell us a little bit more about how many crashes are easy to reproduce for developers and what are the challenges in reproducing them?
Yeah, so reproducing crashes is actually a very kind of, it is a difficult problem, and it is an open problem, and the reproducibility is not always very high. So it depends on what the crash is and what how it was caused, right? So so in some cases it's like, oh, if you click on profile, it will crash, right? So it's just someone landed a change that crashes the whole, like a whole part of the app, let's say. So and this is just a hypothetical example. So in that case, everyone who's every time we run, we will hit this crash, right? So reproducibility would be very high. It's very easy to reproduce, right? But there are some crashes that are caused by, let's say, memory issues. So then that only happens if you're like fall into a part of the app that causes the memory to be consumed, and then you go to this part that is buggy and then it crashes, right? So then that scenario is much more dependent on time as well, right? Because it could be that, especially that you have the back end responding and stuff, right? And we don't control the back end. So then you can, what happens is that you can run the same exact sequence again, and you wouldn't hit the same crash. But there's also another problem with reproducibility of crashes, is that just reproducing the same sequence, it is also a challenge, because the app, even if you get the same app and everything, because little things like just the app taking a little bit too long to load, and then, oh, you didn't find the crash, because you can't wait indefinitely, you can't wait. So we always have timeouts, and then if the app takes too long to load, then you didn't find the same button that you're supposed to click next, then it will fail reproducing the sequence. So it would even never get to the point where you reproduce the crash. Yeah, and then there's some cases where the crashes are just non-deterministic, right? So there's something at the back end that is something in the code that is random, and then it only fails for specific random values. So then you just have to. So we actually have an intern working on this right now, reproducibility of crashes, and the way we want to deal with it is that you can. Instead of running once and saying, okay, I couldn't reproduce, you just, if the developer wants to check if they fixed the crash, then we would like have a reproducibility rate that we have calculated before for this crash. And then based on that reproducibility rate, we say, oh, this usually we find this 30% of the time. We ran 100 times and we didn't find it. So we're like, we have high confidence that you fixed it, for example. Or so the lower the reproducibility rate, then the more you run to have some kind of confidence about if it was fixed or not, or if they want to reproduce it just to see some debug information or something. So we can just use the reproducibility rate to run enough to produce one run that has the crash.
I see. So we have a follow-up question from Nadia. So he is asking, did you think about implementing some checkpointing system during Sapiens execution? Is it maybe too expensive? And also, thank you for answering the questions.
Yeah, thank you. So yes, it is very expensive. It's expensive too. So I suppose what you mean is to take a snapshot of the emulator, for example, and then start from that point. It's very expensive because we need to do it many times because of scalability, right? So it could be a good solution for, let's say, a smaller company, or if someone's working on their own app or something like that. But if you have if you need to run thousands of times every day, then it becomes very expensive because it will slow down, just like the saving of the snapshot and and you have to think, how many times do you have to take a snapshot? Because you don't know that you're going to crash. So you have to continuously take a snapshot so that when you crash, you can go back to that checkpoint. But we actually have another team at Facebook, which is also an acquisition coming from academia, which is called, and this team is working on reproducibility of a binary, basically. So what they do is, like, every run, they save all the calls that are outside of your binary. So if you call the network, if you call the system, any call you do, they would save that. And then when you run again, instead of calling the network again and calling the system, they would just return those values that you saw before. So it's kind of like you would have 100% reproducibility in terms of anything unrelated to your code itself. So then that could maybe help a lot with the reproducibility of crashes. This is kind of the
so
kind
may
of
I,
thing we're thinking
what is the name of that?
Direction we're thinking of going.
May I ask what is the name of the tool? Or you said also coming from academia. Is there a paper we can look it up?
I have to look it up. So the
or
name.
The group?
Let me. So the lead of that is called Ryan Newton.
Okay.
I can check. Yeah, but I'll have to check to see where.
Okay.
Any paper or something. I can share it with you after the.
Yeah, maybe put on Slack if it's interesting for the students. Okay, great. So I'm checking to see if there are any other questions. So okay, there is another question from Italo Santos. I'm reading it. There is too much difference between using Sapiens to test user interface of Facebook app from testing the user interface in the desktop version. So the question is there much difference between using Sapiens to test user interface of an app from testing the user interface in the desktop version related to coverage of tests or bugs that are found?
Yeah, so for the web version, it's a different class of issues, right? So first to start, the way the Sapiens works, we developed it in a way that the algorithm is independent of which platform you're working on. So we have like the algorithm and then we have like the core of Sapiens, and then you have something we call the system driver or something, right? So the thing that asks the screen what's on the screen and then tells the screen what to click, right? So in that way, if you want to support any other platform, like for example, when we supported the web or iOS or something, all we have to do is implement those two components. The algorithm would still be the same, right? So this makes the algorithm almost identical, not almost, exactly identical for all platforms. So when we on iOS or Android or the desktop, it will be the same in terms of the ranking and the choices and everything. In terms of the type of issues we find with the web version, with the desktop version, it's early days, but there are no crashes, right? So it's not like it's a crash per se that you're finding. So it's more like JavaScript crashes or something. So like when so it's not that the app is crashing, but there's like something on the screen, like an error message. So we find more of those type of things, and maybe fatal errors at the back end or something. Yeah, so that's the difference.
And another question from Nadia. I keep asking questions since we have time a bit, so I hope that's fine. And everybody, please feel free to post questions. So this is a summer school and students should interact with their lecturer. So Nadia is asking another question. Have you considered automatically porting crashing tests in the app to tests in the web app or vice versa?
I'm sorry, I didn't get that question. Automatically porting
crashing tests that you found in the app to test in the web and vice versa. Yeah.
That is difficult because we didn't think of that. It's interesting, but I would expect it to be a bit difficult because the interface is completely different. I can see this as being something actually we could try for two different platforms like Android and iOS, right? Because you might have the same type of thing, but I feel like web versus mobile. Mobile is always kind of whatever you see on the screen is minimized as much as possible because it has to fit on this small screen. So the layout would be complete. The composition of the pages might be completely different to web. So it's going to be a bit difficult to map. But I can see this as very interesting for like Android, iOS. So test on Android. Found a crash. Let's move it to iOS and see if we find the same crash. I think that's a very interesting idea.
Sounds good. So I also have a question, which is a more high level. So where do you see the future directions for your work and for Sapiens? So you were talking about crashes. Are there other critical areas of interest for Facebook? Yeah, please tell.
Yeah, definitely. So we have started actually to try to find other issues other than crashes. So for example, one of the biggest ones is performance regressions. That's one that is very important and affects our users just as much as crashes, if not more, because if the app crashes, maybe it will, I don't know actually how many times it crashes for the average user, because us as employees, we get like the untested version, so it crashes for us a lot more than other people. But let's say it crashes once in a while, so it's bad that it crashes. But what is worse is if the performance is bad, right? If you open the app and it takes too long to load, that will happen every time you open the app. So performance regressions are a very high priority, and Sapiens is actually testing for those because we don't need to add anything. We just run, and the performance people just check the numbers because they have these ways of checking if the performance regressed or not. So And we also have, we also work with the people that care about the UI quality. So they also have things in the code that captures if like things are overlapping, or like things on the screen are overlapping by mistake or something. Then again, we just enable it for Sapiens and they collect whatever they want. We also do like, we want to also look at like memory corruption or memory issues, so that someone can put just a hook to check the memory of the emulator, let's say, as Sapiens is running, and then we can find those issues. Basically, the possibilities are endless because we're simulating a human, right? So then whatever you could find with a human, you can find with Sapiens. So that's the model we're working on, is that we run and then we provide the ability for all the different teams that care about any other kind of objective to just kind of collect the data they need as we're running, and then we can help them as well. But we also see like the direction of Sapiens going into more being more of a simulation of real users. So we want to go into the direction of having more realistic users, more realistic. So instead of trying to cover as much as possible, you try to mimic user behavior, because then you can also prioritize the issues you find, right? Because if all my users are behaving like real users, then I can also see like how many of them will face the same crash, and that will help me prioritize fixing the crashes. So I might find 1,000 crashes. So which one do I start with? If my users are simulating user behavior, then I can just take the distribution, and like whichever one I find most, I would go and try to fix that, because I would expect it to have the same pattern in production. While right now, because we're trying to maximize coverage, sometimes we do find crashes that are would never happen in real life, because they only happen for test users. Because, for example, I said we share the state, so they kind of learn the same thing, and then they're learning from the same model, and then they all go in and then take the paths from there, so that they might hit the same issue artificially. So that's what we see. We see like kind of going more into simulating real users instead of just trying to test the app and covering as much as possible. I probably will have both modes. So one to find all the crashes, and one to just kind of get an idea about the distribution and kind of help with prioritizing the fixing.
I see. So how would you do that? Do you plan to have user studies and to collect common patterns or of usage?
Yeah, so collecting common patterns is always like a privacy concern, so we can't do that. But what we can do is we can ask employees to participate. So then it would be limited to a class of users, that because employees would be not representative of all production users, but they would take us a step closer, for example. So we might ask employees to participate in some study. We might just use general kind of user behavior. I mean, we have some people who are like working on reinforcement learning, and not in Sapiens, but in Facebook, like close to us, that suggested that there are some rules you can use. You don't even need to do a study of users. There's some kind of research on simulating user behavior just based on some. I actually didn't even look into it yet, but something like that. And we also, like, for example, on a high level, we know that we know the usage of different parts of the app, for example. So we know that let's say how many people, like most people like newsfeed. I'm making up stuff now, but just like as an example, it's like people like newsfeed, like everyone opens their feed and scrolls. That's like a lot of people go to feed, and then, for example, marketplace, there's like a percentage of users. even on a high level, it can help if you just know that, oh, you need to focus the most on newsfeed, and then marketplace is also kind of popular, but this part of the app no one goes to as much, right? So then if you just put those numbers of hit rate that we know just on a generic kind of high level, and use that to direct the users, then you might get a more realistic kind of, more realistic representation, instead of going and hitting this corner part of the app just because our users kind of found it, while in reality real users rarely go there or something.
Okay, thank you very much. And I'm just monitoring to see if we have any other questions, but if there will be more, maybe Nadia, you can respond on Slack even
Yes,
after your slot. And thank you again for being so gracious to give a talk on a Saturday evening in London.
Thank you very much. I'm happy
and I would like, to send my applause from the audience.
Oh, thank you. Thank you very much. Thanks.
And okay, so this, I guess, concludes the first lecture. And now people will have time to move. You'll need to move to a different Zoom room for the joint lecture of Claire. And I guess Jonathan will post the Zoom meeting for the other lecture.
Yeah, we'll make sure that it's posted in Slack. So this is a good time just to check in and make sure that everyone who's here has also gotten into the ISSTA Slack. And
Okay.
I will paste that link in the chat
And
here.
It will be, and they should typically check the announcements channel, is it?
Yeah.
Okay, or the summer school, or both?
Both.
Okay, that's a good.
Okay, my question is how to get into Facebook. Like I have tried many times applying into Facebook, but I could not able to complete the application process itself.
Okay,
so any
please.
suggestions?
I'm sorry, you weren't able to complete the application process? Well, I didn't understand. As in, just email me and I'll see how to help you with that.
Okay, fine. And your email address, just ping it on chat so that